All right. So our learning target states that I can explain how the convection current in the asthenosphere causes movement at the plate boundary. So this this learning target is important because we need to know what causes and the reason that we have earthquakes, how certain land features are formed, and we have earthquakes, volcanoes, and certain land features such as mountains, ridges, and faults. What part of the mantle, what part of the earth or the compositional layer is the asthenosphere a part of? The mantle, that upper mantle, thank you. And what takes place in the mantle?
What?
What takes place?
What takes place?
Yes.
Magnetic. Oceanic crust? Oceanic crust.
In the mantle?
Lithosphere?
Okay, the lithosphere is a part of it.
Oh, wait. The lithosphere?
The lithosphere, asthenosphere, and what's the other one?
Mesosphere?
Mesosphere.
Yeah, I knew that.
All right, so we're gonna learn. I'm gonna explain how convection current and the asthenosphere causes movements at the plate boundary, which then causes divergent boundaries, convergent boundaries, and transform boundaries. All right, so we're gonna watch a quick little demonstration on how convection currents work.
Have you heard that he tried this? Well, here, it seems true for yourself. I've got some soup covering on the bottom of a plastic container, and there's a hot flash right underneath the red thing.
All right, so I'm gonna pause right here. The red, since it's rising, represent what type of temperature? Or hot. Hot or warm? Okay.
As it's heated, the water rises. But I want you to look closely at what is something else. The blue one stops. It's being drawn in.
All right, so the blue represent what type of temperature or what type of water? Cold. And then that brings me to my next question. When something is more dense, it does what? Thank you, Giselle. Say it louder.
It sinks.
And so when something is less dense, it does what?
It rises.
It rises. Good job.
You can see
So which one, Captain said which one is more dense? Which one is more dense?
The cold.
Cold water or the blue?
when it's heated out. And here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food color coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it?
It's biting.
The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep ocean.
So not only do they drive ocean current, they drive currents where?
Deep under the sea.
I'm sorry?
Oh, under the earth.
Outside of, in the earth, the earth's interior.
But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it, so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course. understanding convection currents will help you get a grip on weather systems and the movement of Earth's continents over the eons, and even the workings of a lava lamp. If you want to try this for yourself, click on this link for all the directions you'll need.
Are we gonna do that?
All right, so that's how convection currents work in the earth. All right, so here again, density is the quantity of matter packed into a unit volume of materials. Each substance has a unique density. All right, so convection. Convection is a heat transfer by the movement of liquid and gases. So that's again, warm air rises, cool air sinks. As the cool air is moving in, the warm air rises, filling those spaces, as stated in the video. Then we have how convection currents, when fluids are heated, the particles gain energy and spread out. This causes their density to change. Convection only happens in fluids. So it doesn't happen in solids, just only in fluids. The density of a substance depends upon the number of particles in a given space. So the tightly packed those particles are, or how loosely packed those particles are, such as here and there. Depending on the density, the fluids will either sink or rise or sink. The arrows represent the movement of the air in the convection current above the radiator. Convection currents help us heat up home, cook food, pans, and ovens, to even cause wind on the coast. All right, so boiling water is an example. As that heat at the bottom pushes up, it pushes the cool water down, causing it to all be warm and boil. And the same things happen in the Earth's interior. What'd you say? Right, exactly. So the mantle gets heat from the outer core, and it pushes the heat up, and as the cool air sinks, it's just a cycle of warming of the earth. As a result, the plates sink into the subduction zone. We get magma pushes the plates away. Which, if they pushes the plates away, what kind of plate boundary is that? Divergent. And then we get oceanic ridges, and then trenches, which is at a subduction zone. All right, here's an example of how it works. This is a simulation of how the magma in the mantle or the asthenosphere is circulated throughout. All right, so what does this have to do with the Earth? The main type of heat transfer inside the Earth is convection. Again, the convection takes place right here in the asthenosphere. And our main takeaways from the convection curves is number one. Someone read number one, the main takeaways. David. Thank you. The convection currents flow within the mantle, also known as the asthenosphere. And then next, number two, Jace. This causes the tectonic plates in the lithosphere to move. Number three, Zayden.
Less dense hot magma moves upward, rises.
Thank you. So those are the main takeaways from convection currents. And as a result of these convection currents, we get geological features that causes the plate boundaries to move. Convection currents causes the lithospheric tectonic plates to move again. And the main source of the heat comes from where, Gianni? Gian, sorry, Carlos. The core in the mantle. Sorry. All right, so for your independent practice, I'll do one with you guys, and then you guys will go ahead and work with your collaborative partner. So the directions. So now, let me back it up a little bit. So now that we learned how convection currents work in the asthenosphere, we're going to take a minute to match them We're gonna take a minute to match the vocabulary words where it's supposed to be at on the diagram. Cool material is what? It's just what?
Like it's material.
Material that's cool. Then we have warm material is what?
Material.
Warm material that's warm. Then we have rises. What does that mean? Something rises. It just go up. Sorry, guys. And then if it sinks, it what? And then we know that the core is what?
The source of the heat.
The source of the heat. And then what's the asthenosphere? Is the thank you. Is the actual layer where the convection currents occur, and then we have the crust. The crust is the what? The Earth's surface, or the most outer layer, and then heats the mantle. So that's all you have to do. Just match these where it's supposed to go. Let's do the first one together. Let me go back. Sorry.
I'm sending Elijah to put his book bag over there because he's the only one who has one with him.
All right, let me find it for you guys. All right, so I'm gonna do the first one with you guys. Let's start with the cool material. Where would the cool material be at? So right, okay, maybe about right here. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 vocabulary words that needs to be placed correctly. If you are unable to correct these, 4 out of 8 is 50%. If you get 5 or more, that means we're on the road. We know what we're doing. Anything under 4, we might need to review. All right, we got it? All right, I'm gonna put the timer on and go ahead and get started. Go ahead. Work with Alex. Come work with Jason. Come work with Jason. All right. I'm gonna come around and check to check in to make sure you guys are working. All right, so I need you guys to talk with your partners.
I told you.
All right, go to the classroom. You have to make a copy. You should have to make a copy in order to complete it. Evelyn did that.
Oh, that. The chart. This one? The charge. Wait, what's for the chart? Obviously. To make a copy. What did you send him? This is old material, right? What are you going to do over here? Goodbye. Goodbye. Okay. Isaac, do you have somebody, what is it? Do you have his charger?
All right, you guys have about 2 more minutes left. All right. All right. Last phrase, last sentence, and last word. All right, good job working together. Next, go ahead and close your Chromebook. Did you guys make corrections with your partners? All right. So now we're going to move on to our last activity of the day. Well, you still have to have your formative, but after that, before that. All right, so. All right, so In the beginning of the year, I gave you guys a survey, an interest survey, and you guys filled it out. I still have them. And you guys told me your family, the people in your family, the amount of people you had in your family, what do you guys do, how you spend time, and what your family consists of. So, for our student asset question, you're going to imagine traveling to the center of the earth. How would you get there? What tools could you use? Who in your family would you take with you and why? You need to consider the temperature, the density, and the material of each layer. I provided you guys with a word bank. Have you guys ever seen the movie,
Yes.
Journey to the Center of the Earth?
Yeah.
Okay.
This person was
All right, so I provided you guys with some words to get you started. Journey, tunnel, drill, spacesuit, helmet, map, compass, flashlight, rope, backpack, oxygen tank, family, adventure, explorer, underground, cave, lava, heat, dark, safe, brave, health, guide, science, engineer, friend, sister, brother, parent, support, discover, excited. So, you're going to use your what?
Imagination.
You have to use your imagination mixed with actual factual things that we just learned about traveling through the middle of the earth. So, once you get to the core, what kind of materials are the core? The outer core, what type of materials on the outer core?
Nickel. No, that's
Nickel is nickel and iron, but is it solid or liquid?
It's solid and liquid.
Solid.
Like plastic.
It's liquid and then it goes back to solid. So you guys keep those things in mind as you are writing. Go ahead and turn to your note taker.
And guys, pay attention, how many questions they are asking in that paragraph. How many questions? Try, when you write, answer all those questions. Okay?
So with that in mind, it's 3 question marks.
3 question marks over there, so that means it's 3 questions. So and when you start writing down, answer the first, then the second and the third question. Okay?
All right, we ready? All set? I'm gonna put the timer on and we're gonna get started. You're gonna write independently. Close your Chromebooks. David, close your Chromebook. Randy, can you start writing, please? use extra paper. You write in about the travel, instead of the current. Make it up. And you should make it. You know, like, you know, make it right, you guys have about 1 more minute.